This is about navigation. Another great job for you to have in the military is to be a navigator. Like in the Air Force, you are the person that helps chart out the course of the plane around storms, through and around mountain ranges, etc. Navigation on a ship, you are plotting the course that your fleet or your ship will go so that you can go from one spot on the earth around to another location. Navigation. Good stuff. Uses trigonometry. This problem is going to use the law of cosines. And I know that because the information that we are given looks like this. Side, angle, side. It's almost like we can get a shortcut here and say, if you have side, angle, side information, you have the law of cosines. What we're missing is the side on the across from the 33-degree angle. Law of cosines will say A is equal to b squared plus c squared minus 2bc cosine of A. Now there are technically 3 law of cosines because there are technically 3 angles, but they all have the same structure. The outsides and the included angle. And so that's what I'm showing here is 85, oh, it's square rooted. Okay, 85 squared plus 368 squared minus 2 times 85 times 368 times cosine of 33 degrees, square root of that answer. That's going to be what we need to know for A. A is orange. A doesn't answer part A, but it does give us the mathematics that we need. So I'm going to plug all of this into the calculator and solve. It's 85 squared. I'm going to do square root first. So control x squared makes our calculator have, oh my gosh, that glare is so bad. I'm sorry. Have a square root. Then I'm going to go 85 squared plus 368 squared minus 2 times 85 times 368 times the cosine of 33 degrees. We always want to use the acute angle measure, so 33 is less than 90. That means this distance right here is 300.303 miles. Now, if the plane, answer the question, if the plane was going to travel from Pittsburgh to New York, and that's 368 miles, then the original trip was only going to be 368 miles. The additional miles will be the total new trip minus the original. So the original is 368. But the total new trip is 85 plus 303. So 85 miles plus 300.303, and that'll be our additional. 85 plus 300.303 minus 368. So 85 plus the answer minus 368. I get a value of 14 extra miles. 14.308 extra miles. Okay. Let's answer part B. Suppose that a commercial jet burns an average of 11.875 liters per kilometer, and the cost of fuel is $3.16 per gallon. How much did this alteration in route cost the airline company? Notice this is measured in miles, and this is a measurement in kilometers. So the first thing we're going to need to do is turn 11.875 liters per kilometer into gallons per mile. So I'm going to start with that. I'm going to go 11.875 liters per kilometer. I got to turn this into miles per gallon. Miles per gallon. Gallons per mile. I want gallons per mile. Okay. So to do this, first of all, I need to know some conversion factors. I need my phone to give me some of the resources. No idea where it went. Okay. The number of kilometers in a mile is about 1.62. So multiplying our original fraction by 1.62 kilometers per mile allows us to cross and cancel out. I'm trying to remember my unit conversions because my resources are not available. Okay, I now have miles, but I got to turn liters into gallons through this conversion ratio in order to have the amount of gallons per mile that oh my gosh, gallons per mile. That's intense. Jets, they burn so much fuel. Okay, so I think, is it 3.081? I'm afraid to mess with my computer on this one, so hold up. Phone. Hey Siri, where are you? I need to know the liters to gallons conversion. So let's go. Liters to gallons. Search. Go. You are the reason this is going to be a longer video. Liters to gallons. Search. Convert. Okay, let's go find Chrome. Chrome will be better. Shout out. Skip forward. Convert. 0.264 gallons for 1 liter. So liters will cross out, and now I just got to multiply all of this. 11.875 times 1.62 times 0.264. I get 5.0787 gallons per mile. Okay, now I go back to this problem, and it's going to be 14 extra miles. So my 14.308 miles, I'm going to multiply by 5.0787 gallons per 1 mile. Miles will cancel. And this is going to tell me how much more fuel the jet is going to use to make that trip. So multiplying 5.0787 times 14.3028. 72 gallons of fuel more to do this. 72.6396 gallons. Now, one more thing is being told. It costs $3.16 per gallon. So if I take 72.6396 gallons and multiply by $3.16 per 1 gallon, gallons cancel. So then I'm going to multiply here by $3.16. It's an extra $229.54. 229.54. So just that cost of saying, all right, I got to drive this way to get, I got to fly this way to get around the storm. I'm going to fly 15 miles that way, and then I'm going to cut back across. You're adding, no, it wasn't 15. You're adding so much more in money. That's a cost effectiveness that airline pilots have to take into consideration as well. Certainly there's advice from the ground to let them know, but there's a lot to consider in these types of problems. Okay, to reiterate, law of cosines. Put the information into the law of cosines. Calculate. Figure out the actual question, how many additional miles, and determine that through calculation. Use some extremely advanced, well, it's just unit analysis for a basic chemistry class, but through unit analysis, figure out the extra amount of cost to alter the course from a direct flight instead to go around a storm to wind up at your destination. That has been it for this entire video. Thank you for liking, commenting, and subscribing. We have Talk the Talk, which wraps up the entire topic, but you have had the chance to learn about law of sines, law of cosines, and put them into practice. Thank you for liking, commenting, and subscribing. I'll see you in the next episode.